right, last section of chapter 2, measure of position, as in, where does it end up? And I know you've seen that second word before, quartiles, but you've probably never really talked about the first word, which is fractiles. They're very closely related. A quartile is a specific type of fractile. And all a fractile is, and I think I have it this way, is a number that partitions or divides, or the number that gives a partition or divides an ordered data set into equal parts. Okay. It could be 200 parts, all right, or it could be 2 parts, really. There's a number that divides it up into 2 parts. Right? That would be halves. Right? And probably the most commonly used, actually there's 3 fairly commonly used fractiles. And the first one we're going to talk about is a quartile, which of course, it's a fractal that divides an ordered set of data into quarters. Right? That's why it's called a quartile. Quartiles a lot of times when you start doing the box and whisker. Yeah. But if you were very observant, you already know how the graphing calculators will give you those numbers. Okay. Apparently many of you were not very observant based on your faces. All right, so the first thing, if you are going to try and divide the order into quarters, well, you can't just start from here and say, let's do it like this. Because as you notice, in both of these definitions, it says the data has to be ordered. So your first step, put it in order. Does it have to be least to greatest, greatest to least? Not really, but normally it's put least to greatest. So what do we got? Least is 5, and we probably better cross it off as we go so we don't miss any. 7. Is there even a 10? Yeah. No 12? No.
15.
You sure there wasn't a duplicate in there? No?
16.
It looks like we got a good run going here, though, right?
2 18s.
There we go, 2 18s. I'm going to run out of room, I think.
20. 21. 37.
Like so? Yeah. And again, it's probably a good idea to check. I'm supposed to have how many? Well, according to this, 15, right? 1, 2, 3, 4. All right, good. Now, probably the most common thing that you do first, and I'm not liking this, I'm going to have to rewrite this, but the first thing you do first is find which quartile.
Median.
Yeah, the median, which is known as quartile 2. Okay? And basically that splits the data in half. Okay? And remember, we're going to go with the standard way of doing that. So you just cross off the 5, cross off the 37, cross off the 21, cross that off, and you cross. Notice I'm not completely crossing it because I know I'm going to have to come back to it. And then this 18 with that one, this 11 with that 18, this 17 with that, that 14 with it. Oh, hey, there it is. So the 15 here is the median, which is quartile 2. And remember what I said about that median is that only works when you have to take that mean in the middle. That flat out, that in this case is the only answer. You know, I can't pick 14 and have it work out like that other problem I did. All right, 15 is the only one that works. Okay. Now to find basically the first quartile would have to come from this data. Now remember, if quartile 2 would have been in between those numbers, remember that? Let's say there was another number in here like a 15 and a 17, and I was trying to find that median in there. Would you use this 15 when going to find quartile 1?
Yes.
And would you use 17 when going to find quartile 3? Yes, you would. Okay. It's basically whatever's left over is what you have to use, and well, 15's been used up. Okay, and sometimes I tell people, put a box around that darn thing so you don't use it again. Right? So I have to use the 14, and so you kind of work your way in again to find quartile 1. Very simple. And, oh, there it is. So that would be called quartile 1. And we'll do blue. I got 18. and what would we call it? Quartile 3. So have we found the first, second, and third quartiles? Again, why are they called that? It says here quartile is a fractal that divides an ordered data set into quarters. So do you agree, if I just forget about those three numbers, pretend they're not there, 3 pieces of data are here, correct, to the left of quartile 1? 3 are between quartile 1 and 2. 3 are between 2 and 3, and 3 to the right of 3. Do you agree that between each of those, a quarter of the data is there, based on a number of it? Yeah, 3, 3, 3, and 3, there's something that splits it into quarters. That's the whole idea. Okay, so any questions on that? Something you've seen before, not too hard. Something that this book doesn't use very well is the IQR, interquartile range. And of course I put it in IQR in parentheses because from here on out I will only be using IQR because I don't want to have to write that out every time. Okay? Anybody remember what that is? Yeah. Wow, good vocabulary there too. The range from quartile 1 to 3, I mean, that's really what it is. That might even be better than what I have. I don't know. Yeah, it kind of is. I just said the difference between the first and third quartile, but range works good too. Yep. So in other words, Q3 minus Q1 in formula form. I must really have something down at the bottom of this for it to be looking like that, huh?
No, it's zoomed out.
When I did when I moved this?
Yeah.
There we go. Well, what is the IQR then? Well, what was Q3? Was what, 18 minus Q1. So IQR is 8. And that's about all this book talks about it. That's 8. And then they're done. They're like, whatever, it's IQR. I don't care. Okay. So the book and I will have a slight discrepancy as we go a little bit further with this example. All right. Box and whiskers. I think we all know what that is, right? Let's see if I can find a spot for this. There, right? An exploratory, I bet you never saw this coming, this kind of definition. An exploratory data analysis tool that highlights the important features of a data set. Yeah, that's fine, yeah. But really, you don't think of it, but it does kind of highlight some of the main numbers. It really does. And the best thing is to actually take one box and whiskers and compare it to another. That's where you can really speed things up. And believe it or not, the TI-83s do box and whiskers too. And as I had a note here, to construct a box and whiskers plot, you must know the following values. And sometimes they are called the 5-number summary, is sometimes how it is referred. And not coincidentally because there are 5 numbers. The minimum entry, well, that makes sense, right? And what is that in this case? For our example, what is the minimum entry? 5, right? The first quartile, well, 10. The median, or quartile 2, was it 15? Yeah. Okay, third quartile, 18. And maximum, 37. Now that's what the book says. I kind of think that it's really good to have actually a 6-number summary because I think it's important to know the IQR. I really do. And so we know that's 8. All right, so draw a box and whiskers plot to represent the 5 test scores. So obviously what you're going to do is I like to put it, well, there's a dot at 5, right? There you go. And I can already see where mine are, but that's right. Put a dot at 10 because that's one of your values, right? Put one at 15. Put one at, what, 18? Can you guys see them too, or is it just me? All right, and 37. Now, can I told you IQR was an important value. Can you actually plot the IQR on here? I mean, I'm not going to go to 8 and put a dot, all right? And maybe that's why they don't count it as one of these values. But then basically what you do, you agree this is what, quartile 1, right? Here's quartile 2, and here's quartile 3. Your first step is to, well, you could draw lines if you want. I don't really put a box around it first, but the reason I like to put the box around it first is because there's a decision that has to be made with your whiskers. According to this book, you just do this. And that's where I have a slight disagreement with this book. It's not because they put a little cross in the middle here. Some people do that. That's fine. But I think it's important to decide, because let's face it, there's one value here that if we got rid of it, it would change this big time. Right? I mean, especially the mean would get changed incredibly if there's one value that got taken out of here. And we know that value to be called a or an outlier. Right? Who remembers, and this is the book's answer, and it's wrong. If you follow the majority of the rules that people will tell you. And that is if you have an outlier, you don't connect it. Agreed? Just don't connect the thing. I believe they have. And it's obvious, I think, that 37 is the outlier. How do you figure that out, though? Close. You take the IQR, which is 8 in this case, and you actually multiply it by 1.5. That gives you how far out from the box it can go either way and still be an acceptable data. So, well, what is 1.5 times 8? Okay, I'm hoping you can start doing some of those in your head, because if you take 8 times 1, that's 8. 8 times a half is 4. You just add them together, right? So that's telling me, in other words, I can take this box right here and put 1.5 of them either way, and I'd be okay, and still count that data. Well, if I'm sitting here at, what is this here, right here, 18, and I go out here, I can go all the way to, whoops, actually hit it when you do it. But I can go all the way to 30, and it's okay, right? Agree that's what it's saying? Is that within that range? No. How about going the other way? I can actually go all the way to -2, right?
Yeah.
So I think we're okay with the 5, because I can go quite a ways going from that one. But yeah, we have a problem here, so we're going to have to fix that. First thing by stopping it from doing that. Go away. Well, we got to leave that point there. What is the next value? 21 is the next closest one? Really? Huh. Well, 21 I think we can agree would be, where am I at here? Do you agree 21 should be connected though? Right? Is it really that far off? Wow. Okay. But does that point still get graphed? Yeah, it's still an important point. You just don't connect it. You know? And here, let's use, oh, I erased it. I was just going to use that one and put it there, but there you go. Again, if you look at this, what does that tell you? 37, outlier. 5? That's good. 21? Good. And it even tells you the median's 15. You know. Now remember, what that means, basically, is if I look from here to the left, what percent of the data should be there? 25% of the data. Okay. From, how about between those two blue lines? There better be 25. Well, what if I move this blue line and move it over to here? 50. And what if I move this blue line and put it way over here? Oh, yep, you got to put the eraser down. Yeah, you get it. I mean, that's the whole idea of quartiles. Each one of them should be 25% of the data. Obviously, if I go all the way down here, I mean, that's 100% of the data. Okay. So, the book and I having a slight discrepancy, but it's one of the first times, so I guess that's all right. Exactly, it goes all the way. Yep, good question. It goes all the way from Q3 all the way out there. Now, does this look like way more than 25% of the data? Right, but we're saying entries, 24% of the data entries, not necessarily of the mean, you know, or anything like. Because remember, let's face it, we're not really doing any averaging here, right? So it's just saying 25% of the entries would be there. Because what that tells you mean why am I not connecting it? It tells everybody else out there so they don't have to go and do that whole math of the interquartile range times 1.5. It tells them that is an outlier. That if you did come back to this problem and you did want to do the mean, that's going to cause a problem. Or an extreme value, sometimes called. Okay. It kind of pulls, you notice what it does though, is it pulls your data that way. Do you see how small this part of the box is? You know, compared to that side? It pulls data that way when really we don't want it to. Okay? I don't even know what's next. Oh, all right. Quartile. I made yours a little bigger because you're going to have to write a little bit, and I obviously typed it, so I knew it was going to fit. Quartiles. Let's face it, I think we know what that means, right? The summary is that it divides data into 4 equal parts, and you should know the symbols. And what do we use for symbols there? We use Q1, Q2, I mean, that's what we use, right? But you notice it's quartiles, and how many of them there are there, though? There's only 3. Does that make sense? There's quartiles, but there's not 4 of them. Some people get confused with that. We're like, how come there's not 4 of them? Because you got to the left, in between, and to the right. You agree that it does split it into 4 pieces? Okay, so deciles. Very good, 10. Have you heard that done before? You know, top 10%, bottom 20%. You've heard that, right? I mean, those are deciles. What do you suppose they use for that? D, not 1 through 10. D, 1 through 9. And the 3 dots in there is an ellipsis, meaning that it covers all the ones in between. Okay. And so if you were, say, at D7, what percent of the data would you expect to be to the right of D7? 30%. Very good. Okay. And percentiles is probably one of the most used, actually, whenever talking about, especially where you're at in your life right now, ACT scores, SAT scores, class rank and all that, it's all percentiles, all right? And here's where a lot of people get messed up, and in fact, my doctor even messed this up once. Divide data into 100 equal parts, and it goes from 1 to 99. I was told that my son's size of his head was in the 100th percentile. I'm like, that's impossible. You know, it goes to 99. There's only, because 99 goes from 99 to 100. Basically, it's the 99th percentile. And I'm like, that's impossible. When he told me he's in the 100th percentile. I'm like, I know my kid's head's big, but that's not even possible. So this is actual data. I should probably cite it. Sorry about that. 1996 SAT scores. Notice it starts off kind of slow there. But hopefully you don't get a 400. I think you kind of get that for showing up and paying your money. But then you see some people got almost a 1600, right? But do you notice, does it really go to 100? If you drew a line across, does it really actually get up there? No, it doesn't, all right? Because they took it and they found all these points. 99th percentile. There is no higher. Because really, if you think about it, it kind of goes, well, we'll talk about that some other time. All right, so here we go. Let's do the best we can using this graph here. What test score represents the 64th percentile? Well, how are you going to do that? You gotta go from about 64, as close as you can, right? I think I just did pretty good. And then once you find that, then go from there and go down, right? What score is that? Yeah, I got about 1,100. That's about what I got. I think if you use the actual data, it was 1,090. So that's pretty good. We said 1,100, right? That's not bad. Now, what does that mean, though? It says, how should you interpret this? I guess you could look at it that way, or you could say that because it helps to know background information. And let's say you didn't know background information, you wouldn't be able to, say that that's better because maybe scoring a 400 is awesome. You know what I mean? You don't know that. And something else, you know what I mean? No, scoring 400 could have been awesome in something else. So obviously you had background information. So you have to get more general and say that 64% of the students that took whatever this is, again, you have background information, scored 1,100 or less. Okay? Or you could say that 36% scored 1,100 or more. Because do you really know that 1,600 is like a max score? Or do you know the max score? No. So, you don't know. And so you don't want to say that either. Say higher than that. You see what I mean? You got to be careful because maybe you don't know. Okay. So, any questions? All right.